Welcome back to the GoEngineer YouTube channel. I'm Eric Weber. In today's webinar, we will cover how to use SOLIDWORKS Electrical Schematic to show the wiring schematics of a DIY drone. Before we get started, make sure to hit the subscribe button if you haven't already. With that, here's Brandon Smith to start us off.
Okay, we are just after the top of the hour. Good morning, good afternoon to those that are able to join today's presentation on SolidWorks Electrical Schematics. My name is Brandon Smith. I am the Electrical Sales Specialist with GoEngineer, and I have presenting today Eric Weber, one of our Senior Application Engineers, who will be presenting on SolidWorks Electrical. So before we start talking about SolidWorks Electrical specifically, I'd like to share with you what we have observed over the past couple of years in the industry. We've seen that electrical designers, regardless of their company size or product's design, generally follow a three-step process in the electrical system design. First, they draw their schematic to establish the logical definition. Then they select parts from online or printed catalogs and draw any special cables or other components needed for needing fabrication. And next, typically they have to document their system in a way that's useful for different audiences, right? For example, a designer might scan through their drawing to construct a bill of material or document each wire connection to make a from-to list. And this typically results in many manually created spreadsheets, wire lists, bill of materials, and other reports that need to be completed before the end of the project. And finally, since the spreadsheets are in no way linked to the CAD files, all documents must be regularly audited. The problem of ensuring these documents are accurate becomes exponentially more complex as more designers collaborate on the project. And really, the purpose of SolidWorks Electrical is twofold. With the powerful schematic creation tool, SolidWorks Electrical helps designers work more efficiently. SolidWorks Electrical features time-saving tools that help designers get their jobs done faster. And also, it includes powerful project management tools that keep track of all project details and updates. So any changes made in one area of a project will be reflected in other relevant areas. For example, if we were to substitute a switch on a schematic for an alternate part, any reference to that switch in the bill of materials, the wiring lists, or other documentations will reflect that change. So effectively, we're fully automated the time-consuming and error-prone process of creating, updating, and checking many separate project documents. Now, today's demonstration that Eric will be presenting to us has he will show us the key benefits of SolidWorks Electrical, primarily faster schematic creation with fewer errors. Additionally, the easy data reuse and new content setup, as well as rapid change management, and finally, professional and accurate final documentation. So with that said, I'm going to turn things over to Eric Weber, who's going to be presenting for us today. We do have the chat and question box up. If time permitting, we will answer those questions. Otherwise, follow up with an email to answer any questions that may come up. Thank you for your time, and Eric, take it away.
Good morning and good afternoon, everyone. As Brandon said, my name is Eric Weber, and today I'll be showing SolidWorks Electrical. So we'll do a few different things. We will start with creating a project, and then creating a couple of schematics and showing you the process of doing that. And then lastly, we'll do a single line diagram to kind of show a summary of what our whole system looks like. And then we'll talk a little bit about reporting and showing how to export these to PDFs and kind of looking at our smart PDF tool. So here I'm just starting out in SolidWorks Electrical, and when I go to my projects manager, you see I've got all of my projects that have previously been worked on, and then from here I can create a new document. Now, The documents always start with a project template. So here I've got my drone project template selected. So when I hit OK, I can enter in any information that's relevant to my project here. So I can just first give this a name. So we'll just call it drone schematic um, demo, and I can also, fill in any information that would be useful for me. So you'll see that Electrical has a lot of text boxes for data that we could use in different locations, whether that's in our title block or with our next to our symbols. So we can control where this information appears, control what information we want to use. So here on the project properties, there's really not a ton that I'm going to use today, but this is something that you'll notice in a lot of these menus. So here I've just got the description in there as drone schematic. So once I hit OK, it will create our project. So SolidWorks Electrical works on a SQL database, so it's very fast in easily searchable, and also allows us to collaborate with others. So, if I make a change to something, that gets updated in the SQL database in the project, and then if another user needs to come in and make changes or look at the documents, they can do that as well, and just connect to the same SQL database and same project. So once I create a project, there are several things that get brought in from our project template. Okay, so a lot of these are different options that we have. So when you first go through and set up a project template, you can go through and create all of these, or enter in all of your settings, and then equations for how things get labeled, how things are marked. We'll see later what my wire label kind of looks like here. Different equations for how the wires get numbered, and how our different components get named kind of automatically. So a lot of these settings, again, are stored in the document template. And then also, a big one is our wire style. So you'll see that I've got a specific set of wires here that I use for these drone projects. So these wire styles are all saved in the project template that allow me, access to those wires. So we'll get started here on this project. So the first thing I'm going to do is set up some locations. So locations are actual physical locations on, on your machine, or in this case, the drone that we may want to document to help find where different components are when actually doing the physical wiring. Again, this is something that's optional. A lot of this stuff is optional. You use what you want to, but I wanted to quick show what this looks like. So what I'm going to do is create a new top level location. So it gives us an automatic location mark, which is L2, and then I can give it a name, and we'll just call this arm. Okay, so the initial one was drone body, and then I have my arm location. Now on the drone body, we have some sub locations, so I can choose that and then just say create several locations, and I'm actually going to create 3 sub locations. So I can hit OK there. So now we have an L1, L1 sub location, L1, L2, and so on. So if I edit this property now, I can give this a description. So we'll call this one bottom plate. And then the next one we'll call middle. And lastly, our top plate. So again, the body itself has some different sublocations. All right. So with those done, now I can create start creating my drawing. So to create a schematic, all we need to do is right-click on our book here and just say New Scheme. And you see here that it creates a new sheet. Now, if I open this up, you can kind of see the title block that was stored in the project template is pulled up. Again, that can be mapped. You can use some default title blocks for different types of drawings. In this case, we're just kind of using a blank sheet with a little bit of text down below. Now, we're going to set a property here for this first sheet to kind of give it a name. So I'm going to call this one, we're just going to call this motor control. And when I do that, you'll see it gives a name here for us. So now I'm going to just start inserting my symbols. So typically I like to work where I insert all my symbols and then draw wires. There's a lot of flexibility with SolidWorks Electrical. So if you like to insert symbols, draw some wires, you can certainly do that. There's a lot of flexibility when working with the project. So what I'm going to do is first kind of insert all of my symbols. So when I say insert symbol, it sort of remembers the last one I've used. But when you click other symbol here, it brings us into kind of a search mode. So we can kind of search by classification, or we can use our search filters. So the first thing I'm going to do is insert my motor symbol. Now, my motor here specifically is a DC motor, so I can come out and find what I want and then just hit select. So now I'm ready to place this. So electrical works on a snap. So as I move this along, you can see we can snap our symbols in place, which allows us to draw the wire connections for that. So if I just kind of zoom in here and I can place this symbol, but with a left click, you'll see that it brings me into my symbol properties. So the first thing you'll notice is it automatically gets a root for the component name, which is M in this case, and then the first number available, which is M1. We can pick the location here. So, here it will put it on the drone body page, but in this case, we want to put it in the arm location. And then we can go ahead and assign a specific manufacturer's part. So a lot of the symbols in electrical are general in the fact that we can, we may use the same symbol, motor symbol, for example, in this case, but it may represent many different types of manufacturers' parts. So we also have a library full of manufactured parts that we can customize, that we can enter in. So when we apply a general symbol, we also want to signify which exact manufactured part that is. So I can search here as well. And again, it sort of starts filtering based on the symbol that I inserted. So if I just hit search, it actually just gives me a list of DC motors. So in this case, I want this one, and I can just hit add. Now over here, we see that our states are all green. This just means that the symbol that I used has the same type of circuit as our manufacturer part. Okay, so there's a check here to make sure that the symbol you're using matches, that of the manufacturer's part. So everything's green there. So if I hit select and then OK, it inserts that specific motor. Okay. So there again, you can see, if I just exit out of here, you can see that I've got the manufacturer, I have the root, the manufacturer, and then also a description here, and then what my connection points are labeled. So these red dots are connection points that will draw wires to and from. One thing I actually forgot to do was set this actually to my arm location. So that's so I'm going to set this drawing sheet to the arm location, and then we'll just change the location here. So now you see that the location of this sheet is L2. So when I insert symbols, now it will automatically put those symbols in that location for us. All right, so then I'm next going to do insert an electronic speed controller. So these are under our electronic component classification. So if I hit OK there, you'll see that I have this symbol that I've created. So this is a custom symbol that I created, and it's specific, to our drone projects. So I can actually rotate that and just kind of put it in line with our motor, so we can draw nice straight wires for that. So if I click there, you can see that my root turns into E. I want to actually edit that, so I can call this ESC for electronic speed controller. And here now you notice that it goes into that arm location automatically. Now, again, once we insert a symbol, we want to assign a specific manufacturer's part. So here you see these speed controllers have a couple of circuits for power supply, and then circuits to connect to the motor, essentially. So if I do a search here now, again, it searches our manufacturer part library for anything that has this motor classification. So in this case, I want to grab my speed controller, and then I can add that to the symbol, and there you see that it has our 5 different circuits with 2 connection points per circuit here, and then a single one for the power supply, or 2 circuits for the power supply. So if I hit select there and hit OK, you can see again that symbol is brought in, and we get that information with our connection points labeled. And then next I'm going to insert our power distribution board. So this is something that distributes power to each of our motors. So I can drop this in here as well, kind of keep it in line with our speed controller circuits. And then if I jump over to manufacturer's parts, notice that my manufacturer part is already assigned. So when you have part specific symbols, like I do in this case, I have this complex symbol with a a complex list of circuits. We can actually take a symbol and pre-assign a manufacturer's part to that. So that's what I've done here. So you can see that there's really no searching I need to do at this point. So if I hit OK, now you can see that we've got our distribution board in there as well. Okay, so then the next thing I need to insert is what we call the power module. So this basically connects our distribution board to our battery. So I can insert this, and we'll call this one PM for power module, and then click OK, and there you see, again, that one had a component already assigned to it, so you see the information there. And then lastly, for this sheet, we'll put in our battery. So again, I'm going to use just a general symbol. So if I go to power supplies and choose a battery symbol, we can do that. And I'll just drop the battery over here somewhere to give me some space. So in this case, again, I'm using a general symbol, so I want to assign a manufacturer's part. And then if I search, you can see I've got this lithium polymer battery that has been created as well. So I can hit OK there. Now, again, these symbols can have as much text as you want. So as part of creating manufacturer's parts, we can include things like manufacturers and descriptions and that sort of stuff, and we assign those attributes to our different symbols here. So at this point, I'm going to go ahead and start drawing some wires here. Or excuse me, actually before that, we'll actually create what we call location outline. So recall that I set my location to our ARM location, but the power distribution, power module, and battery are actually located in a different location. So I can create what's called the location outline that allows me to signify where these are located. So if I just gather all of these into a location outline. These all actually sit on my bottom plate sublocation. So when I select that, it gives me a message saying, do you want to change those component locations? So again, I'm going to say yes. And what that does is it takes each component and actually moves them to that location when I do that. So now if we kind of expand our components list, you'll see that I have the motor and the electronic speed controller on my arm. And then if I look at the location of the battery, the distribution board and the power module, those are all located on on the bottom plate there. All right, so then next we will draw our wires here. So first we'll just draw some wires between the motor and the electronic speed controllers. So there's a few different ways to do this. One is to draw multiple wires, and the other is to draw single wires. So in this case, I'm going to grab my wires here. We're going to use a 14 gauge wire, and notice that it's a grouping of 3 wires. We have white, black, and red. So I'm just going to select that wire style, and then I just click on this connection point and bring this across to the ESC. Click again, and there you see I've got my wires. Now in the middle here, you see that the wire label automatically showed up. When we number each of our wires, we'll see that those boxes will get filled in. The wire labels are fully customizable, so we can have this kind of show us a color if we want. In this case, it's showing the gauge of each wire, so that's why you see the 14 there. And then we'll next add our wires that go to the distribution board. So I'm going to actually grab some 18 gauge wire for this, and again it's just a white, black, red. So I'm going to bring this over here and not quite connect it right now, because I'm going to actually create a macro, because I need to make 3 more of these setups. So I'll just show you how to create a macro here shortly. And then lastly, we're going to use our power, the 18 gauge power here, and we can hit select, and here we're just going to do our positive and our negative. We want to invert that, so I'm going to actually invert the phase, so our black is positive and red is negative in this case. Okay, so there we've got a basically the components that go on the arm of the drone. So now what I want to do is create a macro for this. So actually I've got this one in here. Let me just delete this, and I'll show you how to recreate it. So if I just box select everything here, you see that it selects the symbols and and our wires, and all I have to do is drag and drop this into my macros window, and then I can give it a name, and we can hit OK. So once I do this, you see that it gets stored in my panel here, and then I can sort of reuse this as needed. So if I just drag and drop now, you can see that it does this paste special. So when we paste in a macro, there's some things that we may want to change. So in this case, the stuff that's been assigned to these symbols and wires are locations. So we're going to just say keep the same location. Remove wire numbers. We don't actually have any yet, so that doesn't matter. Component, we're actually going to create 2 new marks. So we're going to get M2 in ESC2 when I do this. And then the wire styles, we're just going to keep the same wire styles. So, you can see that the location 2 is associated, and it would create new wire numbers. Again, we don't have those yet. The location is associated, and then all of our wire styles are going to be the same. So once I hit finish here, you'll see what happens. It actually created M2 and ESC2 and assigned those manufactured parts for us automatically. Actually, I inserted that a little off center, so let me fix that. I'm just going to move this over a notch. Okay. And then I'll next just kind of insert these next ones here. And I can just hit finish. I don't need to go through that. So now I have M3 and ESC3. And then I'll grab this last one here and drop that into place. All right, so now we have everything, that's related to the arm there. But now I need to make these connections. So I'm going to go ahead and just do a modify and stretch. So what we want to do is just stretch these wires and make them connect. So we've got our points there, and then I can just make that connection. And now you see that the connection's there because my wire labels pop in there as well. Okay, and then we also need to finish off the wires from the distribution board. So we're going to go ahead and draw just some single wires in here. So I'm going to first do a green wire, and I can bring that out. And I'm not going to connect it to anything right now. So we'll do green and then orange, white, and yellow. So I'll grab orange for these next connections. And yellow here. And then we'll also bring in our power wires. So this time we're going to do the 18 gauge power. And there we've got that. Okay. So now we are ready to connect the power from the power module to the power distribution board. So again, we'll use, for this one, we're going to use our 13 gauge wires. And then I can, now draw this in here. Oh, I got to make sure I turn this one on. So we've got that. And then I actually, to make sure my plus goes to plus, I need to just hit the space bar and actually invert these so these connect up to the symbol the way we want it to. And then we'll do the same thing down here for our, to connect this to the battery. So in this case, I'm just going to draw the red wire first. And then we can draw in the black wire. So I'm just going to pick the black wire from this grouping. Okay. Now, you'll notice that when I do this, again, some of these segments get the label, and perhaps I don't want it on these short segments. So I'm able to actually kind of multi-select these and then just right-click and say hide wire labels, so we can hide those where we don't want them. And then next we will create the power module where we're going to run this out to the flight controller eventually. So I'm going to grab this this grouping here, and I'm going to actually change the spacing to 0.75. So when I do that, you'll see that the wires are then split a little bit further, so they go down to the next connection point. And then lastly, we're going to do a couple of control wires. So I'm going to do a black wire. Now, when I choose a single wire, when we call it draw single wire, that means draw a single wire style. We can actually draw multiple of these at the same time. And so when I have it selected as 2, you see that those black wires come in there as well. Or I can draw those 2 at the same time. So at this point, I'll go ahead and just number the wires just to kind of see what that process is. So all I need to do is click number new wires, and then I hit OK. And you see that now it's numbered these wires. Again, we can have more complex numbering than this. Here I just have a simple 1, 2, 3, 4. We could put in equations that include the rows and columns if we have our project set up that way. But in this case, it's just going left to right and then top to bottom. So you see here 1 and 2, and then it goes down a row 3, 4, 5, 6, 7, 8, and then it goes to 9, 10. So as we work our way through this, you see that everything that's connected to something has a wire number. Now these wires here, kind of on the right side, aren't connected to anything yet, so we need to do that or create the second schematic, and then we'll bring those across. So I'm going to go ahead and create a new schematic, and then I can open that up, and then I will add the properties here. So this is going to be our drone body, and then I can give this a description. So this will I'll just call this flight controller or autopilot. And I can click OK. So that changes, or that gives our drawing a name. So now I'm going to insert the symbols for this. And this, again, are some pretty custom symbols. So when I go to my schematic here, I'm going to find the different symbols that I need. So again, these are under electronic components. And there's a few different things I want to put in here. So the first is our autopilot. We'll rotate that, and I can just sort of place that, somewhere down here, just kind of knowing what I need to bring in there. So we can call this FC for flight controller. And again, the manufacturer part is already assigned because this is a pretty custom symbol. And then next, we're going to put in the RC receiver. So I can grab that symbol, orient that the right way, and we can drop this into place. And I'm going to leave a lot of room here because some of these wires get we get a lot of crossing going on. So I'm just going to leave myself some room. So there, if I give it a name. Again, the manufacturer part is already signed because I've done that in the symbol. So there we've got that. And then lastly, I'm going to insert my GPS symbol, which is again under my sensors here. So I'll bring that over, and then again I'll just give it some space here and place that. So I can give this a name, and we can see our manufacturer part once again is assigned there. Okay. So, at this point, I'm going to draw in the remaining wires. So the first thing I'm going to do is bring in my wires from our previous sheet, so I can just draw those out, and then we'll draw this single wire style. I'll do my black wires, and then the colored wires connect to our outputs down here. So I'll go ahead and bring those in here. So those are going to be our 18 gauge single wires. So we'll grab, first we'll do our yellow wire. That goes to our 4. Got to make sure I bring this back down to a single wire. And then that's going to go to that circuit. And then we'll do our white wire. And then orange. And finally the green wire. Okay, and then over here where the power is controlled, we'll bring in our 18 gauge 18 gauge wire. So there I've got, did it again. Got to make sure I change this back to the 0.25 spacing, and we can pull this down. And then lastly, we'll bring these across. And then our black wire. Okay, so those are now connected. So now we just need to connect these to our receiver. So this is where we can kind of get, you know, a little bit more complex. So the first thing I'm going to do is run my power once again. I'll put a spacing of 0.25, and we can grab our power from here. And then if I click, I can kind of do a 90-degree and then click again to get that drawn. And then we'll do our single wires. So first we're going to have a red wire going from our second channel here. And this goes all the way over to our OS3. Or sorry, our IS3. Okay. And next we'll do green. And this goes all the way over here. Then we've got yellow. Blue and orange, so we'll do the blue one. This actually goes straight down, and orange will go from here to our fifth input. All right, so there again, you know, we have some segments that we, you know, can kind of overlap here. So I'm actually going to hide the wire label there. We'll hide the wire label here, and I can put those on, you know, our different segments, so we don't see all that crossing going on. And I'll remove this one as well. Okay. Now, if we want to move these around, we certainly can do that by just clicking and dragging those. It by default will put them on. It will by default put them on the center of the segments that they show up on. So that is something we can change as well. Okay. So then the next thing we want to do, remember, we need to connect these back to our wires on the previous document. So what I'm going to do is create origin destination arrows for this. So when I come into my origin destination, you see that it puts, you know, whatever sheets we're going to work with side by side, and then I can say single insertion. So notice at the ends of these wires, I get this green dot that I can select. So this only works for any wires that are, you know, not drawn to anything. So then when I pick this green wire, it's going to come over on the second sheet, and notice I cannot pick any other wire styles. Okay, so here we're going to do green to green, and then here we'll do orange to orange, and then the white to white, yellow to yellow, black to black, red to red, and then down here, same thing. Now, because these two wires are the same, this is one where you have to kind of be careful. These are just black control wires, so I want to make sure I pick the proper one here. So there you see I'm kind of done and everything. Oops, it's closed down. Electrical. Let me bring that back up. So maybe it's good that I did that. So one of the nice things is notice I've never saved this. That's the beauty of SQL. So as you make things, even if you accidentally close it, there was no saving that needed to be done. It actually saved everything that I've done. Notice the last thing I did here was the origin destination arrows. So maybe that's a good thing that happened to me. So one of the nice things as well is these origin destination arrows are smart. So it actually there is an equation set up basically saying that this is on sheet 1 and then on row 10. Okay. Now, if I right click on this, you can actually say go to the origin arrow. And when I do that, notice it actually brings me over to sheet 1 and zooms me in on that exact location. If I go here and say go to destination arrow, it will zoom me into the yellow wire where that's connected. Okay, so you see that those are kind of smart arrows and allows us to navigate the project. So now I need to number wires again, and I can go ahead and renumber these wires. And there you see we get our additional wires that haven't been numbered yet. And you'll even see if I go back to my first drawing here that these now have their numbers as well. Okay. So then the next thing for this, we can again use our location outlines to represent where these different components are. So if I drop in the location outline for the receiver, this is actually on my bottom plate. So I can select that and then change the component location. The GPS is going to be on the top plate. So I can set that up, grab my top plate, and change the component location. And then the flight controller is actually on the middle plate. So we can grab that. We just want to make sure we grab the full symbol to get that moved. And then that's on the middle plate. And then we can change. All right, so here again, we've got kind of some overlap, so I can clean that up and just kind of move that over. So the different colors that we have representing this can be changed. So like our location outlines, are a specific color. They're a dark purple. I could change this text to dark purple as well to kind of keep that a little bit more organized. So now if I jump back over to my components, now you see that the specific components got moved to their correct locations. So at the arm, we have our speed controllers and motors. On the top plate, we have the GPS. On the middle plate, we have our flight controller or autopilot. And then at the bottom plate, we've got our power and then also the receiver on that bottom plate. All right, so now we actually need to add some additional components to our bill of material that aren't going to be represented by symbols. So there's actually some quick disconnects between the ESCs and the motors. So, if we need to change these out, there's actually some bullet connectors there. So what I can do is actually I can add a component manufacturer part to this, and this and then if I just hit search, it will find my generic connector. So I want a bullet connector, and I want 12 of these, so 3 for each motor. And we can just hit OK. And so there you see that it has those 12 connectors out at the arm location. And then also on the power distribution board, there's actually some generic connectors that get soldered on there that we'd need to order. So I can actually add, another manufacturer's part here, and we're going to have 4 of these. Okay, so now you see our bill of material includes these additional connectors in their proper locations, but there's no symbolic representation for those. So that's how we can kind of control the bill of material. So then the last thing, or the last sheet we want to make, is our wiring line diagram. So these are actually more general. We don't have individual connections. You can be a little bit more, you can draw these things more in a pictorial way. So in this case, we're going to do, just call this drone overview or something like that. And we'll keep the location at the drone body. So now we have our sheet, and then I'm going to insert specific symbols. So, with these single line diagrams, we have some different symbols that we can use, and my motor's here. So I can just insert this. Now, when I insert that, what it wants to do is create, a new mark. Now, because I've already have this motor 1 in here, this is just another representation of the same component. So I can just grab M1 here, and you see, this symbol is going to, be represented, in 2 places, on the schematic and then also in the single line diagram. So we can insert that one, and then I can insert the second one, and then the third one here, and our fourth one as well. Okay, and then we'll next do our speed controllers. Now again, these symbols can be, you can edit these to give you more information if you want, or we can, have just some simple text, simple description in there as well. So there's 3, and then we'll add 4 here. Okay, so the next logical thing we should insert is our power distribution board. So we can place that here, and again, that's on my bottom plate. So we'll grab that component, and then if you recall, this is connected to our power module. I'll just move that over here, which is, and then this is connected to the battery, so that's under power supplies. And then we've got, it's also on the bottom plate. And then we're going to do our flight controller. Which is on the middle plate. And then we'll just lastly do the receiver and the GPS. So I can grab the GPS first, put that here. That's on our top plate. And then the receiver. Okay, so you can see that, these symbols are, more pictorial representations of what we actually have. And we can, draw the connections between the two. So because we have this done on the schematic, if I go and draw a cable, notice there's no connection points I need to hit. When I go into a symbol, it just gives me that green square there, and then I can connect it to the ESC. Now, if I double click on this line, notice that it knows that there's 3 wires, 1, 3, and 5, and those are, connected to the correct components. So if we go back to this, 1, 3, and 5 are going from M1 to ESC1. So because I've already done that, pretty much the work here has been done. So we can still get that information between the two. So those all connect there, and then these all come into the power distribution board. And then the distribution board goes to the module. Module goes to the battery. Distribution board goes to the flight controller. And then the power module also goes into the flight controller, receiver, and lastly the GPS. So everything kind of leads back to the flight controller pretty much. So again, if I just double click on one of these wires, we can actually see, what's coming from the distribution board and what pin is it actually connected to on the flight controller. So you see that these pins are also labeled based on the circuit that we had, set up already in the schematic. So those are, these pins here coming from the distribution module, if you recall. So that's a quick way to sort of lay out your projects, and once we do all this, again, this is completely optional. This just gives you another type of drawing. The schematics kind of control a lot of the smarts, whereas this is more of an overview of what you have going on. And just kind of showing that, if we reuse a component, or if we have multiple representations of a component, we can actually have these on different sheets. So here again, motor 1, if I just right click and say go to, it will zoom me in on motor 1. If I right click here and say go to, it will zoom me in on motor 1 on the overview. So each component, you can kind of expand those out and see all of the symbolic representations, but they're all representing the same component. Now notice those connectors that we just added to the bill of material don't have anything or they don't have any symbols associated with them, and it's because we just want to include those on our reports. So that brings us into the reports. Now reports, we can have many different types of reports. Here I'm going to have a bill of material and a wire list. We can do things like harnesses and do PLCs and things like that. But these are customizable as well. So if I just come into one of these and go to the properties, you can see I can add different columns from this list. So remember, this all goes back to what information do we want, and what text boxes do I need to fill in when I'm creating a manufacturer's part, or when I'm creating a symbol. When I created my project, we saw all those text boxes for the information that we want, and these all get mapped to these smart reports. So here, if we just look at our bill of material, you'll see that here it's got the reference or the like the part number or the part name, and then the mark that it was given in our project, and then a description of that, and then lastly the quantity. And then our list of wires by line style. So this will actually show us the origin and destination of wire number 1. So remember, that went from motor 1, the W circuit, to the ESC1, the W circuit as well. It tells what our wire style is here. And then the length, We don't have anything filled in for the length. For each of the wires, we can fill in a length. Now, if you have SolidWorks and SolidWorks Electrical 3D, if we use the automatic routing capability with that, it automatically calculates wire lengths. But when we only have the 2D schematic, if we want wire length, we do have to manually enter that. And then lastly, this is just our drawing list, where you can see we've got those things. So now what I want to do is actually generate the drawing. So when I choose all those to generate, what it will actually do is give me a drawing of each of these reports that I have. So when we're looking in the report window, you can see, we can manipulate this stuff and look at it. So now you see that the drawing list actually got, a lot longer. So if I hit OK here now and go to my drawing sheets, you can see if I look at a bill of material sheet, notice this report actually generates a sheet that's broken out by manufacturer. So you see that these are grouped together by the different manufacturers that I'm using. For example, the bullet and the Dean's connector, these are shown, the different marks for those, the description, the quantity. And then because this list is a little bit longer to fit on one sheet, it automatically knows to create a second sheet. And then the same with the wires. Okay, so here these are split out by the wire style that I used. So here you can see origin destination, what the wire number is, the section, and then again length. If we had those included, it would give us the length of each wire and then the overall length for those wire styles. So here you can just kind of see that the number of different wires that I had was a lot longer. So you can kind of see that these tables are moved on to the next sheet. And then the last thing is our drawings list. This actually kind of gives me the table of contents. So you can see that we've got our different drawings here. And if you want to change the order of this, you certainly can do that. I could, maybe move the drawings list here to the front, and then I can simply just renumber the documents for this and just say recalculate. So now, we've got 1, 2, 3, 4. So those now go in the correct order. All right, and then the last thing I just want to do here is export this to a PDF document just to show what we can do with that. So I'm going to put this on an 11 by 17 sheet, and we can give this a name, drone demo, and I can save that out, and we'll just hit export. So when we export this, it will create a PDF of all of our sheets. And when I open this in Adobe, you can see that we can view this with thumbnails, or there's also these bookmarks here that allow me to kind of pick what I want for this. Now, there's also a components list that is real nice because we can also click on these from the list. So here I've clicked on the battery, the schematic representation, but I can also click here and it has a hyperlink to the different locations. So it will automatically zoom you in on those documents. And also, if we click on the PDB, for example, this symbol, it will actually zoom us in onto the other representation of it. So the PDF documents are actually smart in that fashion where we can, use either the bookmarks here, or we can actually just click on the symbols to see other representations. Also, the origin destination arrows do the same thing. If we click on those, it will bring us back and forth through the origin destination arrows. Thanks for watching. If you enjoyed this webinar, please subscribe and leave us a comment below if you have a topic you'd like us to cover in a future video. Visit our website, GoEngineer.com, for access to professional training, upcoming events, and more from your #1 online technical resource.